Elon once said very clearly that the more affordable they can make a car, the better it is for everyone. Since true affordability is the final goal, the starting point cannot simply be swapping batteries or changing materials. The starting point must be reorganizing the entire production system from the ground up. When production lines stop repeating old factory habits, unnecessary steps are deliberately removed, and the sequence of operations is rearranged to follow the movement of materials, workers, and robots. This is the moment when costs begin to drop steadily instead of bouncing up and down. Because of this new thinking, reaching a price near $10,000 stops being something printed on a slide and becomes the natural outcome of a new mindset that is practical, consistent, and measured by clear KPIs at every station on the line. If you want to explore every optimization point inside the Model 2 production line, subscribe to Tesla Byte Hub to help the channel reach 100 subscribers and turn on the notification bell so you do not miss the coming analyses. One subtle change in the Model 2 production line lets cars come out faster and cheaper while still keeping the outside finish clean and smooth. In a normal production line, painting is always one of the most expensive parts of the factory. The paint shop can use up to half of the factory's electricity and create more than 60% of the CO2 released during the production of a single car. Also, 10 to 15% of vehicles must be held for repainting because of dust or surface marks. For the Model 2, Tesla removes the painting step entirely. Instead, the body moves through the line in a raw, unpainted state, and the color and surface finish are added at the final step using prefabricated exterior panels with color already baked in at the supplier. This change has a deep effect on the cost chain because it removes the paint shop, which is both energy-heavy and prone to defects. The direct benefit is a large reduction in the number of cars waiting for paint curing. Throughput improves because the time a car spends inside the plant can drop by around 20 to 30%. For a Model 2 line built for 250,000 cars per year, raising efficiency by just a quarter can add about 60,000 extra cars without increasing the size of the building. In terms of energy use, removing the paint shop saves around 0.6 to 0.8 megawatt-hours per car, cutting energy cost by around $80 per vehicle. At the last station, instead of spending many hours painting, drying, and polishing, the Model 2 only needs about 10 to 12 minutes to attach 4 to 6 large exterior skins like the hood, rear bumper, side panels, and door pieces. 2 or 3 robots handle positioning, fastening, or adhesive bonding, and technicians finish by checking gaps and surface quality. This is extremely short compared to the 6 to 8 hours usually needed for painting and final assembly in a traditional plant. The result is not only faster output but also more stable quality because each robot station is programmed exactly, avoiding human differences between shifts. A special advantage of these color-ready skins goes beyond manufacturing and into ownership. Small scratches or bumps no longer require repainting whole panels. Model 2 owners can simply replace the colored skin, which takes less than 90 minutes at a service center. Repainting the same area would normally take 2 to 3 days and cost about double the amount. The standardized panel design and quick-detach system reduce repair costs by 40 to 60% and improve color durability because skins are produced in a controlled environment before reaching the factory. Tesla's bigger challenge is keeping consistent color and texture across batches. Without painting in the factory, color accuracy must be controlled by the supplier. Tesla can use spectrophotometers to measure color difference of delta E less than 1, which is almost impossible to notice with the human eye. When color and surface quality are well controlled, final assembly becomes mostly mechanical and alignment accuracy can be kept below 0.5 millimeters at the joints, similar to today's premium cars. Overall, color-ready skins help the Model 2 reach 3 targets at the same time: lower energy use, faster assembly, and cheaper repairs. A factory using this method can save around 20% of total production cost per vehicle and cut VOC paint emissions by about half. More importantly, Model 2 buyers, usually middle-income customers who want a strong, affordable, and easy-to-maintain vehicle, benefit directly through less downtime, cheaper repairs, and higher resale value. So color-ready skins are not just a trick for saving cost, but a clear sign of Tesla's reverse production mindset for the Model 2. By removing one of the most expensive steps in the industry, Tesla cuts cost, while also redefining how a low-cost car can stay high quality. This is only the first step in a long chain of changes aimed at redesigning every operation from the powertrain stage to final inspection, all toward the same goal, making the Model 2 a truly reachable electric car for everyone. 6 hours of painting compared to 10 minutes of skin installation makes it obvious that Model 2 wins if Tesla's approach truly makes more sense. Another quiet change on the Model 2 line may be the key to making it truly affordable. Normally, drivetrain assembly is the most delicate part because even very small mistakes in shafts, torque, or cooling hoses can create vibration, noise, or leaks after a few thousand miles. For more than a century, automakers have broken this job into many small sub-assemblies to reduce risk. No one wanted to merge them into one unit because of error buildup and the chance of slowing production. That changed with the Model 2. Tesla does not treat the powertrain as many parts combined, but as one unified block. The motor, inverter, gearbox, cooling pipes, and modular battery packs are all built together on a single standard pallet. That pallet is lifted and aligned into the car in one motion. This replaces the older method that needs 3 to 5 different stations. With only one positioning step, robots tighten bolts with programmed torque and angle, sensors confirm accuracy, and the car moves to the next test. In simple words, Tesla installs the Model 2's heart in one step instead of building it piece by piece. Fewer stations naturally mean a faster rhythm. A realistic goal for one assembly point like this is 35 to 40 cars per hour. Running 2 shifts for 50 weeks per year equals around 280,000 cars from one optimized station. The process is not just faster, but more consistent because there's only one major joint. Rework rates can stay below 1%. The Model 2 battery pack follows the same idea. Instead of one large, hard-to-replace block, it is divided into 2 or 3 modules with their own cooling and high-voltage connectors. If one module fails, technicians can isolate power, drain coolant, remove the cover, and replace only that module in around 2 hours. A Model 3 or Model Y pack, which weighs 400 to 600 kilograms, can take 2 to 3 days to replace under warranty. The modular plan cuts downtime and warranty cost by 30 to 50% over 5 years. From a factory design view, building the whole power module on a pallet gives the Model 2 flexibility to switch designs or suppliers quickly. When improving a motor or gearbox, engineers only need to update the pallet layout, check bolt spots, and reprogram robots. The goal is to keep downtime under 24 hours per configuration change, including testing for cooling and high-voltage safety. Every hour of downtime costs money, so this flexibility offers real savings. For quality checks, assembling everything as one block simplifies inspections. The Model 2 can use alignment sensors for guide pins, 3D cameras to check gaps, and save torque data for every bolt. Cooling lines use quick connect fittings with pressure sensors to catch leaks instantly. Early detection reduces rework, lowers final inspection time, and ensures the Model 2 feels solid and refined when driving. A long-term benefit is the ability to remanufacture the entire module after 3 to 5 years. Since everything is standardized, service centers can recover working battery modules, equalize them, test impedance, and rebuild certified packs. Motors can be vibration tested and have bearings replaced before being added back to inventory. This reduces waste and lowers repair cost, especially good for owners who keep their cars long-term. All of this comes from one simple idea: turning the drivetrain from a multi-step process into a single installation. Fewer steps mean faster production. Fewer joints mean fewer alignment mistakes. Modular design means cheaper and quicker repairs. This is a change at the architecture level, not just a tweak. Once the architecture is clean and standardized, cost drops hand in hand with reliability. Another often ignored benefit is that this pallet method lets Tesla change suppliers without stopping the line for long. By only changing the pallet design, checking hole patterns, and updating robot programs, Tesla can change a motor or gearbox supplier with less than a day of downtime. This helps keep prices stable because Tesla can choose the most cost-effective supplier each quarter. Finally, the Model 2's power module can be fully remanufactured, with rebalance packs, refreshed bearings, and checked inverters returned as certified parts. This means the Model 2 is not only affordable to buy, but also affordable to keep for many years. At the final stage of the line, Tesla makes another important change that can reduce delays and improve affordability. Normally, every final check is pushed through one long chain where all tests move at the same slow pace. The Model 2 changes that. Tesla splits the final inspection into two speeds. There's a very fast speed for things that can be automated like electronics and software, and a slower speed for things people truly feel, such as water leaks or vibrations. By separating them, Tesla achieves two things. Fast items move quickly while sensitive items get tested more deeply without slowing the entire chain. At the fast speed, the Model 2 checks electronics in around 8 to 10 minutes. This is reasonable compared to 10 to 12 minutes on many C-segment German cars, where sensors must be unplugged and plugged manually. The Model 2 can measure directly over CAN and internal networks, making the 8 to 10-minute target believable. Tesla wants a software defect rate below 0.5%. Many car makers accept 1 to 3% because they must send cars to a reflash area. Tesla fixes small bugs over the air on the line, removing the need for a reflash island. This area is where many factories get stuck. When it goes down, the whole shipping flow slows. Avoiding that keeps throughput stable, and when throughput is stable, cost per car falls. At the slower speed, Tesla tests things customers notice right away. First is leak testing inside a rain chamber for 3 to 5 minutes. Japanese and German factories usually test for 7 to 9 minutes, but Tesla can reduce time because the water paths are standardized and built with lower variation. After the rain test, the car goes to noise and vibration simulation for 4 to 6 minutes. Traditional plants often require 7 to 12 minutes because they must run many load profiles. Tesla uses a 95% real-world city driving noise profile, which is more accurate and faster. This makes under 1% leak failures possible and allows small problems to be fixed in under 15 minutes. Small issues are fixed immediately instead of going into large rework piles. But the biggest change is not the test itself. It is what happens after testing. When the Model 2 passes final inspection, it does not go to a long-term parking lot. It is assigned directly to the nearest delivery hub. In auto logistics, 15 to 45% of storage cost happens in this final phase. Long parking time leads to small defects like humidity buildup, sticky parts, and tiny scratches. Tesla removes this entire part of the process. The goal is to deliver the car from vehicle identification point to the customer's door in no more than 72 hours, within a 500 to 800 kilometer range. If Tesla reaches this target, finished inventory can drop by half to almost 70%, and storage-related defects can drop by 20 to 30%. In simple terms, the final inspection of the Model 2 is built on one clear idea. Test fast what can be tested fast. Test carefully what the customer notices immediately. And when the car is ready, do not let it sit. Deliver it quickly. This is how Tesla cuts EV cost. Not by using cheaper materials, but by cutting the time a car stays stuck inside the factory. This reduces manufacturing cost in a way customers can feel. Almost every automaker talks about this lever, but never fully applies it. Tesla is using it. That is why a $10,000 EV no longer sounds impossible. Affordability is not a slogan for the Model 2. It comes from cleaner flows on the line, quick electronic checks, strict water and noise tests, and smart choices like modular packs and pre-colored skins that reduce waiting, waste, and rework. When a car spends fewer hours inside the plant and fewer days in storage, cost falls in a way buyers can see. If these plans stay consistent, the $10,000 target stops sounding like a dream and starts looking like a real plan.